Well, want to welcome you guys to the GOTUG, the Geospatial Transportation Users Group. Our webinar is going to go from 1 p.m. to 2:30 p.m. Eastern Time. And I'm just going to move on over to the next thing. So our agenda today, I'll do just a kind of a quick welcome and overview. I have a couple slides for that. And we have two technical presentations. An interactive HTML5 GIS data visualization. See what's inaccessible. Cardo Vista from Danny Bouchard. And we'll have a question and answer after that. So go ahead and use your questions thing and type in your questions, and I'll just kind of keep track of that. And I'll bring them up after Danny's presentation. And then after that, we will have a presentation on WeatherView from Cody and Barrett, and Mark McCart. And Mark, he's not going to be here today, so it's just going to be Cody. And they are from the Iowa DOT, and they will also have a question and answer after theirs. If anyone is interested in presenting or has an idea for a webinar topic, please contact Penelope or Jeremy, and their emails are currently on the screen, and they'll be splashed again at the end of this presentation. Okay, so just a quick history and future of GOTUG. Our key people, there's co-chairs, Caitlin from Utah DOT and Jeremy from North Carolina DOT, and then our AASHTO liaison is Penelope. What is GOTUG? It's our Geospatial Online Transportation Users Group. It began as an AASHTO initiative, an innovation initiative initiated by Utah. And it was a project that was a working group under the Standard Committee on Planning, a subcommittee on data, and now GOTUG is part of the Committee on Data Management and Analytics. The GOTUG steering committee is Caitlin from Utah DOT, Jeremy from North Carolina DOT, Eric from Iowa DOT, Andrew from the Texas Transportation Institute, myself, Nicole Hansen from the Idaho Transportation Department, Mark from FHWA, and it's supported by Penelope from AASHTO. So why GOTUG? It maintains the momentum started up with the UPlan AASHTO innovation initiatives and marries business needs with innovative web-based geospatial solutions. Since changing the distribution to the self-enrolling method, the list has actually tripled, so invite your friends and forward it around to get on our distribution list. Oh, sorry. Okay, so coming up, the next webinar is December 7th. It's the capability maturity for GIS. And then March 6th, we haven't quite gotten the subject yet, so if you have any ideas, go ahead and let Penelope or Jeremy know. And there will be another full session at GIST on the Geographical Information System for Transportation in April. Okay, so I'm going to just introduce Danny to you guys. Danny Bouchard is the founder and CEO of Cardo Vista, a Canadian software company specialized in web mapping and data visualization, using interactive maps. As a physical geographer with over 25 years of experience with GIS, Mr. Bouchard is highly interested in all aspects of web mapping and cartography, how to deliver faster, actionable maps for better decision making. So now, okay, so now I've changed the presenter over to Danny.
All right, so I guess everyone should see my screen right now. So thanks a lot, Nicole, for the introduction. So this is what I wanted to share with you today. It's all about interactive HTML5, GIS data visualization, and what can be done today with web technologies. I'm hoping this will highlight some of the key uses of HTML5 and what it can bring to GIS data. So in a nutshell, here's what I wanted to share with you. I'm just going to go back here to the overview. Just going to make this a little smaller here. Go back to my overview. All right, so the canvas of my presentation goes as follows. I will have a quick introduction. We'll talk about a few of the key concepts and what we found. We'll talk about web publishing, some of the styling options. We'll take a look at the tooling. And also I'll have some key use cases in GIS and transportation in particular. And we'll end the presentation with a few examples of live maps. So why don't we start? So how does this all start? So what we found, what we see in essentially in the market is a big gap between the GIS and the business users. The GIS people are talking a language that is obviously quite different than the business user. The business user have their own term. They don't know about layers. They don't know about data structure necessarily. They sure don't know about projection and georeferencing. So the challenge we see is how can we bridge the gap? There is really an opportunity with HTML5. GIS traditionally used to be only on the desktop, and really the GIS people used to only be able to reach and talk to themselves. Nowadays with the web, there's an opportunity to reach those guys, but obviously there are some challenges in the way you can expose some of those things and the way you can do it on the web. So let's look a little bit in more details. Obviously, HTML5 has a huge benefit of being supported on web and mobile. It's very often we see business people coming to meetings with their iPad. So it's nowadays accepted that everything should work properly on mobile devices. I'm sure if we ask all the people that are attending this webinar, all of you have a cell phone, and it's key that applications developed with those technologies will be responsive. It is expected to be like that. Now, something that's really good about HTML5 is it also provides an extremely rich framework in terms of rendering. So there is a lot of very nice graphic effects you can set up and you can think about using in your maps. And for me, as a cartographer and a geographer, I really enjoy and try to use those and leverage those as much as possible. Now, in terms of design, this is where it's a key element. How are you going to design your user interface so that the business people is not lost, they see the value, and they get it right away. All right, so the business people want to make a decision based on the data. They want to be able to visualize it. So the less time they spend looking at your maps, the less time they spend thinking about, loading them and all those things is so much better. Time is money, obviously, in the case of business decision. Second point is, very often we need to look at the nitty-gritty details, but we also need to look at the summary insights. So aggregating data at different geographic level, being able to see the global picture is key. Something else that we've seen as a global trend in the industry is the business people are looking for more and more self-service. They want to be able to play with the data. They want to change the things. They want to change the representation. They don't want to go back to their GIS people all the time to change things on the map. So there's a certain level of freedom that they expect to be able to deal with. Something else too that's key for them is having access to live information as much as possible, or external data is also a key thing in the business. So how is it possible, and how let me share a little bit of our experience at CartaVista, how we've designed the experience in terms of web mapping. So we have defined a clear separation of the base map and the subject data. The subject data being the data you're interested in. So obviously the base map in this case is in raster format. We also have the subject data, which is vector in JSON, which is very common, GeoJSON, and we have the data which can be either JSON or XML. That separation of the data, the geography from the actual data, gives us really nice data binding capability. So we can bind all that data together and make it meaningful in the browser. All right, so let's take a little bit a step back to look at the tooling. Everything starts from GIS data. So what we have essentially is a publisher, which is a desktop app where you can load your GIS data and simply publish to HTML. So I'm just going to show quickly how that works. So in this example, what I'm doing is I'm bringing in a shapefile of insurance policy. It's just a drag and drop. When I do that, it's created a new map file. You can easily create a map when that map is created, you can go in and specify how you want to style that layer. I can choose with all the typical options you would find, typical color, halo color. You can set up the style the way you want. And as you would in any normal GIS, you can add your base map layers. Everything is layer based. The interesting part in this case is you can set up multiple data elements. So those are all the columns I have in my table. I can add those essentially as attributes. And then you can decide to configure what happens whenever you roll over those objects on the map. What are you going to show as a data tip? What are you going to show as an information view when you click on with the identify feature? What are you going to show in the data table? So you can choose and pick and choose the columns that you want to expose in the end results. And when you're happy with it, you can just publish. This will create an output that is web ready, that you can just place on any web server and will be working. In this case, the map tiles are coming from a service. They're pre-generated images, and the vector data is JSON. So this loads in the browser. The beauty of this is you get a nice user experience. As you can see, you can interact with those features. You can select, the features get selected, and it is a fully vector-based map and a vector map, essentially. So now let's take a little bit of a look as to what's possible in terms of styling with HTML5. It's extremely rich. The options you have in HTML5 are very interesting, mostly because of the canvas. The HTML5 canvas gives a lot of flexibility. You can create things often you can't really do within GIS. So you can play, for instance, with blend modes. Your layers can really multiply if you want. You can create drop shadow, glows effects, things that usually you can't really find in the GIS space that easily. And the beauty, since it's web-based, you have the potential of allowing your users to change those things as you move along. So let's take an example here. I have a map, typical map of polygons. As you can see, first of all, whenever I'm mousing over a polygon, you notice we have a drop shadow effect. So the canvas really gives us a nice framework to have those level of interactivity. You can highlight features as you move across. You can really create that rich vector interaction with the data. You can also enable interesting effects, like in this example, I'm adding an inner glow, which is defined by a number of pixels. You can change the glow color and all those things. And the key thing is you can start stacking those effects. So I can go in and add, for instance, a drop shadow. The drop shadow, I can start configuring, as you can see in this case, I'm increasing the shadow size. So all of those things are running in your browser. You have access to all those options to really create maps that look different than what you find usually on Google Maps and pretty much the standard looking road type maps. Let's take a closer look at the project we did, just to give you a sense of what you can do. This is with OpenStreetMap data. There was some custom design that we did just to give you an overview of what's possible in a real project. So this is like a community map in Canada. This is in French, but I think you'll get the picture. So first of all, you can see we have some styles that are set up. It's really focusing only in one of the districts. So we have sort of like a blocking effect on the map. We have some layers, some specific projects. So whenever we roll over those points, we show what those projects are. There's some basic information that gets displayed. I can turn on different themes. The themes are turning on different layers. You could see they load fairly fast in the browser because, again, all those layers were preloaded. They're all essentially a bunch of vector JSON files that you just turn on or off in your map. If you have more complex data, such as roads, they can be integrated as well. This is an example we have where we show some new roads, or in this case, a new area that's been constructed. If you have more polygon data like zoning information or construction year, whatever, you can also enable those layers. Some of the zoning layer can be very complex polygons. Sometimes I don't know how they come up with those polygons, but I don't want to ask. So having the rollover effect, as I'm demonstrating right now on the map, is extremely useful, because otherwise you have no real, it's really hard to see. As you can see now, all the polygons look pretty much yellow because it's the same zoning, but having the vector effect as you mouse over is a big plus to allow the user to understand the data better. Okay, moving on to GIS and transportation use case. So the first use case I have for you guys is traffic counts. Obviously, there's a lot of you that are, dealing with traffic counts and everything. We did a little prototype with Dallas, Francisco Torres. So thanks to him to providing us with the data for this demo in particular that I will demonstrate in a second. So in this example, what you can do is you can set up with the CartaVista software a map gallery like the one I have right now. You can go in, pick the different map. You can fully control who gets to see what data. You can go in and add, let's say, a new user, define your permissions, and set up the data access. Once you're happy with the map, you can click on one of them. The map is going to load in the browser. Now, what you see in this sample map that I'm demonstrating right now is a map that has rather a dark design. And we did that on purpose because we wanted the traffic data to really stand out. So we've gone with very light colors and a dark background to make the data stand out a little bit. What you can do as well is change the representation. You can see now I'm changing the calculation of the representation on the fly. You can also change the color of any analysis and do that right there in the browser. Whenever I'm mousing over any of those counts, we actually show the data. I can also choose to customize the opacity, making it less or more opaque. You notice as well that we kind of see through the layer. This is typically the use of the multiply blend mode. Having that access is interesting because then you can have multiple things overlaid. You notice that we have a series of themes. In this case, we can look at different counts, cars by different types, different pickups. We can start interacting with the data. Whenever we're selecting in the dashboard view, which is standard in CartaVista, we have the chart on the right, we have the legend and the table below the map. You can interact with any of those. Those are very common in HTML5 interfaces. People have all those things interacting. And that's one of the power of having all those things working together is you can start filtering, you can start picking your theme of interest, but not only the map, but the surrounding components all sync up. And you're presented with a graphic view that's really meaningful depending on what you're interested in seeing. So in this case, we can look at the different count types by vehicle types. You could see them represented with pie charts on the map with color. Working with color, again, is extremely useful to be able to compare the data. Now, in this case, in this example, we have two different dates. I have date 1 and date 2 represented on the map by two different colors. Now, you can also chart any data that you'd like. In this case, we have hourly traffic. I can pick a specific count, and you could see you can have the comparison of the two dates on the chart being presented on the map. Something else that is interesting, you notice as I'm selecting right now, it's doing the selection in the browser view, but I also have a graphic view of the data, obviously in this case, with the total, and I can sort and compare those two dates visually right there in the browser. Whenever I click on a feature, it is navigating to the corresponding item on the map and is zooming to that location. All right, let's look at what we can do with traffic counts, but in this case, applied to the road segments themselves, so polylines. So this is a similar example, but in this case, instead of attaching, we have the traffic volume attached to the road segments. So very similar style, we have our base fabric, which is still in the dark colors, and we have the road segments, in this case, in light blue. So we can look at volume by size. We can start integrating or querying the data. Whenever I click with the identify tool, I get the corresponding roadways. I can go in and configure actually which attribute should be displayed. So In this case, if we display it all, it's all the tabular data attached that gets displayed. Same goes with lines. I can select from the map, and it's actually giving me the selection in the table, but also in the chart. So it's going to chart only what is selected. So the charts are reactive. They really adapt based on whatever's selected. You notice as well that I can click on a specific item in the bar chart and it zooms to the corresponding item on the map. So I think also people expect nowadays with business intelligence tools and all those things, they expect to have those kinds of functionalities. So if you are developing some UI in HTML5, think about this. Think about the business user. They will want to click on the charts. They will want to click on the legend. They expect those kinds of functionality because that's what they're used to on the BI world. So in terms of color and capability, you can go in, choose whatever you like. But one of the things I really like is we also offer the capability to filter the data. So I can start going in, looking at my theme of interest, but I can also go in and start filtering the data. So you notice that I have some speed limit information like I would have in an Excel spreadsheet. I can easily just create a filter on the map, and it's going to remove all the items that in this case don't fall within the speed limits I selected. That's an extremely interesting way to start not only filtering on one column, but filtering on multiple. In this case, I'm just filtering out the directions of the different highways. So you can only look at specific patterns or specific directions when you look at the entire data set. And the same goes, I can go in, click on a feature, and it's going to navigate. Something else that is interesting, I can decide to choose a theme of interest or choose to build a new theme. You notice I have the speed limit. I can choose how I want this to be represented by, let's say, color categories. When I do that, it's actually creating the theme on the fly. And you notice that I have now the rows that are 60 kilometers per hour or miles per hour in yellow on the map. So that's one of the things that's nice with HTML5 is you really want to empower your users to create their theme of interest if you can. That self-serve experience is very often what the business user are looking for. All right, so let's take an example. We had the pleasure of working with the Census Transportation Planning product, the CTPP maps, as a software company. That was a great project. So I just want to share a little bit our experience and how we integrated our visualization inside those products. All right, so let's take a look first at the CTPP app. This is a comprehensive application. I'm sure maybe some of you are familiar with CTPP. The purpose of the application is to gather a lot of data about the census and also transportation and put those two data sets in relationship. So in this case, what we have, as you can see now on this interface, is the table interface where you can go in and have your different workplace and residence geographies, and then you can click on the map tool. The map tool will open up a Carta Vista map based on whatever geography you have selected, and then you have access to all the thematic mapping functionality. Right now, we're looking at total means of transportation, in the state of Texas. And the same tools apply. As you can see, I have essentially my table. I can go in and zoom to a specific item on the map. I can make selections in that geography. This is going to highlight the corresponding item in the table. So all of the things are syncing up. Something that's different in this application is we have in this app over, I think there's about 100 gigabyte of different information stored in the backend in the cube. So a lot of information is used in the backend, and we are connecting on the fly to that data set and creating the rendering. You're not limited to counties. You can go down to census tract and start looking at more information at the tract level. Something else, obviously, you can start to choose the different measures. This is coming from the data cube in the backend, which is using SQL Server analysis services. So you can pick how you want this to be represented. Let's say a number of people that drove alone. And again, you can choose how you want this to be represented. I can choose, let's say, graduated symbol. So each tract will be, a symbol will be added for each tract. And then you can go and configure how that's going to be displayed in the browser. So a lot of flexibility. You can choose how you want the calculations to be done, whether square root. So something else that is keen is nice is the ability to modify or change the calculations and your ranges. So you can go in and do those things. Notice as well, as I'm zooming in and actually roll over some of those features, we have the margin of error, which is very important in that case because we have inconsistent data sets and coverages. So it was really important for the census data to be to have that concept of margin of error. So now moving on to the next part, this is where I'd like to go deeper into flows. So the Census Transportation Planning Product, CTPP, includes residence to workplace or workplace to residence flows. So we have in CarVista the ability to display those flows in a different way. So we can integrate that in the map quite easily. So the concept is you click on the map to define an origin or a destination. And when you do, you notice it's creating, actually in this case, a flow map. And those flow arrows are added on top of the map. They're color coded, or in this case, graduated based on the number of commuters that are, originating from that county to others. You notice that right now it's only doing 10 flows. Again, if you have so many flows, so many flow arrows, it's really hard to understand the map. I'm gonna zoom in closer. As you can see, whenever I mouse over those lines, it's actually showing me the data. I can choose to increase the number of flows that are displayed. And really, you have all the flexibility to change some of those themes on the map, change how they are represented, or even choose how you'd like the representations to be. You can also just modify to your liking all the different styles and choose to do those representation. Now, you notice as well, the algorithm is designed in such a way to avoid overlap, and sometimes you can't quite avoid them. It's not perfect, but we're still looking for ways to improve that. But the interesting part is when you start comparing multiple flows. So you can hit the shift key and start comparing multiple origin and multiple destination. In this case, we're looking at flows originating from 2 different counties in Pennsylvania. And you could see that each of those records, each of those flows also include, they are a feature on the map. So it's an interesting way to start to look at more complex data. Flows is hard because it's multi-dimensional in nature. And you're not limited to origin to destination. You can also look at flows that are, with the destination, in this case being this county, Clinton County. So a lot of flexibility to design and understand different flows, which is sometimes a hard concept to grasp, especially because there's so much data out there. And the ability to filter and only pick what you want to depict is very key in this context. I think that covers pretty much the transportation. Now moving on to a few other areas where we had lots of fun developing. This one is all about energy trading and live maps. So we had the pleasure of designing this 40 feet dashboard, which is a physical dashboard implemented at Brookfield Renewable, one of our customers. I'd like to show the picture, show you the power of integrating those HTML5 components together. When there's a change in the market, these areas on the map are changing color using WebSockets. We can go and update those. There's live weather information being displayed on those big maps. They're really using this for trading purposes, and it's been extremely useful for that customer to have access to that live data on demand, and everyone in the trading floor can visually see the map. We even designed it in such a way that the fonts are appropriate depending on where you're sitting and everything. So that was a big project for us, but interesting way to take advantage of the HTML5 capabilities. Now, HTML5 being developed in JavaScript, there's a lot of possibilities to take HTML5, adapt it, and change it, and go crazy. So this is an example of what we did in terms of HTML5 and animation capabilities. With Carvista, we have what we call the software development kit. So you can take what we have and build on top of it. So here's an example of a typical map where we may want to look at multiple vehicles or tracking of multiple things moving on the map. So I'll just take the first example here where I have a series of points on the map. I can start playing the journey of those people, in this case, our employees traveling in the morning to the office. As you can see, this is a real map. I can zoom in closer. So HTML5 gives us the capability to take multiple data sets, combine them, animate things. Obviously, you need to ask yourselves a lot of questions about the data, where it's coming from, how you want it updated. But there is a lot of flexibility in the way this can be done. Obviously, I can look at a single person or single person traveling and animate the display and the location as they travel along. So I think, with that being said, there's a lot of potential for HTML5. The fact that this runs inside your own web browser and also your mobile devices is a big plus. So it makes sense to start investing, or at least be intrigued about HTML5 and what can be done with it. That being said, I think that covers pretty much my part. I had just about 30 minutes, so I think I'm right on time. So that being said, I want to thank you.
Cody, you can go ahead.
Okay, all right, thank you. Hello, everyone. Thanks for attending this webinar. My name is Cody Barrett, and unfortunately, my colleague here at the Iowa DOT, Mark McCart, couldn't make it in today. So I'll be kind of going over his role in helping develop the new WeatherView application. He was more the back-end architect of everything for the REST services that's driving the data that you view in the application. I'm Cody Barrett, and we're both embedded consultants for the Iowa DOT through H&TB, and they're based out of Kansas City, Missouri. So I kind of want to just go over a few things first before I dip into the application. I don't know if you guys have gone and checked it out at weatherview.iowadot.gov. One of our biggest initiatives is the open data, at least geospatial open data, and especially open data when it concerns weather, winter operations. And here with WeatherView, I work closely with our Chicago office for HNTB, and we utilize the Scrum methodology and Agile methodology for project management. And we did the web development lifecycle, so planning, analysis, design, implementation, testing, maintenance. And we want to make an iterative process, meaning whenever a change is made, we want to iterate it through, do a user testing, test it on all different devices, and make sure that it's ready for production. So here's a list of the technology that we used. A lot of you, I'm sure, are familiar with the terminology here. We obviously are using ArcGIS Online. We're using Web App Builder, and I like to call Web App Builder as a framework, not as a viewer, because again, you could do SDK. We use the Web App Builder Developer Edition. We utilize ArcGIS Arcade for some of our custom applications or whatnot inside of the web map. We use JSON, GeoJSON to pull the data and parse it. ArcGIS JavaScript API, JavaScript HTML5, CSS. Now jQuery. jQuery is an interesting JavaScript library. I'm not sure if y'all are familiar with it, but it's a fun little library that can do a lot more than just vanilla JavaScript. We utilize that to do multiple things inside the application. I'll kind of go over that as we get through. Data tables, that's another JavaScript library that we use to form a nice visual table. FME, now FME is kind of the engine that we use that really aggregated the data that's being pulled from the sensors, filtered it, used the ETL process, and made it pretty inside of WeatherView. Again, like I mentioned before, the Scrum methodology. And then we use Visual Studio Team Services for our source control to ensure that we have the most up-to-date code and that the code can be viewed by the product owner. So right now I'll do a little demo of the application. So here it is. This is WeatherView. And as you can see, it's kind of messy here in Iowa. We're getting a lot of rain. So we have flood warnings and flood watches. We had tornado warnings actually last night in the northeast part of the state. So right here on the layer list, we have our operational layers. We have AWAS, RWIS. AWAS is basically weather from airport sensors throughout the state, and RWIS, and I'll go over both of these later in the presentation. And RWIS are sensors that are maintained by the Iowa DOT along Iowa DOT roadways. They're just weather sensors. And then you can turn on and off all these different layers here. So the RWIS temperature, turn it on and you can view it. AWAS air temperature, dew point for RWIS and AWAS. We have bridge temperatures, which is really important in the winter. Road temperatures as well, very important in the winter. Wind speed, wind direction, AWAS wind direction, and so on and so forth. And another important one we wanted to include was traffic speed. Traffic speed is pretty important to gauge the amount of traffic that's going through. Users can view, they can zoom in and see which roads that the traffic is heavy on, like in Dubuque here. And then I also wanted to include the National Weather Service watches and warnings and the radar. And we have all of these actually on 2-minute intervals to refresh, because we're running in the background and utilizing FME server. Now I'll get into that more. And this is what Mark maintains, his FME server, of how to utilize near real-time to real-time data. And as you see, the radar just refreshed to where we have the most up-to-date data within the last 1 to 2 minutes. And so as you can see here, we have the RWIS points and the AWAS points. AWAS obviously are the airplanes, and as you hover over it, then you get a little bit of data, a little flash of it, and then if I click on the point, Let it load up, and then you can see here that it's going to come up with all the weather data, as you can see. And there's another tab here called Forecast, and this is the data table. And you can view here that we have 32 hours of forecasted data with road temperature, road frost probability, bridge temperature, bridge frost, air tip. Again, these are all being driven by the REST services that we developed from FME. And then this is the current tab showing all the observation date and time, the atmospheric data, the surface data, the subsurface data. If the site includes this information, traffic data along with deep temperature probes, what the temperature is below the surface of the road. And then here we have our RWIS images. And every minute there's a camera at most RWIS stations or sensors that rotates every minute to snap a photo of each position. And here you can choose a position. So if I wanted to go I-35 roadway, you can see that the last time we pulled that is at 12:20, so about 20 minutes ago. So it should be coming in pretty soon. And here you can actually loop the image. And what this does, and I'll go through the code as well, I'll get a little technical on this of how we grab the latest 10 images within the last 2 hours, and then we loop through to view the images. And so you can see how the weather is over time, over the last hour to 2 hours, and how much it's either getting better or if it's deteriorating and you want to kind of hold up on your travel plans. And you can stop it, play it, go to the next image, next camera position. And one of the things that we really wanted to try to do was still have these tabs. And these tabs are very important so that we keep the information contained within one pop-up. We didn't want to have multiple pop-ups for one location. Close that out. Now, if I go to an airport site, you'll see again, we have the same two tabs here, the current and the forecast. Again, in the current, we're showing the current weather information that the weather sensor at the airport is getting. So you see precipitation is light rain, first cloud later scattered, broken, overcast, visibility is at 10 miles, wind speed. And then we also wanted to have the aerial image of the layout of the airport as well. And I made this a link that pops up in a new tab where you can view actually the airport itself. And then we also have a link to the airport website to get additional information that isn't presented within WeatherView. And we also wanted to do include a pop-up for the flash flood watch, or excuse me, for the warnings and watches for the National Weather Service. And we just got minimal information, the issuance date, expiration date of whatever message type it is, and then just a link to more information. And that's just going to take you to the National Weather Service Forecast Center for your local National Weather Service center. And here you can see flash flood threat. Rain, Wayne, go away. All right, let me go back to the presentation here. Oh, excuse me. Actually, I wanted to show you one more thing here. So another thing we wanted to do is with the old weather view is that we wanted to have an images page that aggregated all the images from all the locations of the RWIS sites and all the camera positions into one area, and we wanted to make it responsive. So when you click on the images link, it takes you to this website, and you can scroll down and see all the different RWIS sites. And if you click on one, I'm using Bootstrap to kind of bring that modal up and expand the size of the image so you have a better idea. You can actually then click up here, and if you wanted to go to Cedar Rapids, type that in, then you can go to Cedar Rapids instead of having to scroll all the way up and down. I'm gonna go to Algona. Another thing that we wanted to ensure was that it's responsive. As Danny had mentioned before with his applications, that you wanted to be able to view on multiple devices. And that was one of the biggest things that we wanted to ensure that we did correctly. So as you can see, as I move this more, shrink and make it larger, you can see how it kind of forms to the size of the screen you're in. So if I want to go single, then you go scroll down. Again, functionality still works for the search. And the same thing for the weather view application itself. So if I want to view it, let's say an iPhone 10, you can see here, whoops, let me refresh it. All right. Actually, let's click on a point here. Let's look at Osceola. You'll see the pop-up is a little bit different, but it is mobile friendly. And again, it has the same functionality as if you're on your desktop. And then for the forecast tab, as you can see, it's a little bit different. Now, one of the things that we wanted to make sure is that when you're on your phone, you don't want to scroll left and right. You want to see whatever's on your screen at that time. And so we use the data tables responsive functionality where you have this little button, this little green plus button. You can't see anything to the left, and I don't want to scroll to the left and right. So I hit the plus button, and it shows the rest of the information so you can still continue to scroll down and view the information. I thought this was a pretty neat way to view it. And then if you wanted to change your county name instead of going back to the map, let's say I want to look at Dallas County, their forecast data. Now it'll give me all of Dallas County, Polk County, give me all the forecast information for that specific county. And then you can also view the images in here as well. Oh, in here as well. I actually went to, again, it just takes one image per the size of your phone. And I can do the search still and view it. Again, we wanted to make sure that it was responsive and works on all operating systems or platforms and devices. All right, let me go back to the presentation. So for the planning of it, we wanted to do a requirements gathering and scope document creation. We worked with the product owner, Tina, at the Iowa DOT within the maintenance department. And we wanted to create an application, again, like I said, that was responsive. And some of the objectives was we want to make sure that it was COTS, commercial off the shelf. So Esri is commercial off the shelf, and we wanted to do a little bit of customizing, but not too much. So we decided to use Web App Builder and utilize an ArcGIS Online web map. Like I mentioned previously, we want to make sure it's responsive, mobile friendly, and that all platforms can utilize the application. Now, part of the web development process, you want to analyze the pros and cons of the old application and then what you want to bring into the new one. So this replaced an old WeatherView application that was not responsive. One of the pros was the county forecast table. We wanted to ensure that we brought that back in. Obviously the RWIS and the AWAS data, and we wanted to have that stationary pop-up that came up in the middle of the screen. It was simple but effective. It really made sure that the user that it grabbed their attention. Some of the cons of the old application, that it was fully custom. It was not commercial off the shelf. And so it was very expensive to upgrade and to maintain. So allegedly there was an $11,000 annual fee to the developer of the application, and anytime an upgrade or an iterative change to the process needed to be made, there was a fee for it. The application was not responsive, and so within mobile, it was actually just tabular. There was no map-centric component, and it utilized the Google Maps API, which we did not want to use that. We wanted to use the ArcGIS JavaScript API and more. All right, and then here's kind of a little overview of the old WeatherView application. It was deployed in 2010. And the programming language that it used was a C# VB programming language. We wanted to kind of simplify that and utilize HTML5, CSS, and JavaScript. And here are the screenshots. As you can see, it was not viewable on a tablet. On the desktop, this is kind of what it looked like before. just kind of bulky, lots of just links. As you can see here, the map satellite, I don't even know what that other button is. Maybe hybrid is off the page. And then here, you can see that it's the tablet form that it only shown on the mobile side. So here's where Mark was. He was huge to the process. This was what he took care of, and he wanted to make sure that we did not have repeat the issues that we had from the old weather feeds. So there was a VB script process that grabbed data from SQL Server and pushed it to Oracle Spatial. There was no monitoring of the job, so if there was any failover, there was no failover. And so people, the job would not work, and we'd have no idea until someone went to use the application and the data was incorrect. A lot of the IDs for relational tables didn't match up with each other, and so there was missing data from that. Data wasn't QC'd correctly, and so it was old and a lot of times not accurate. A very important part of it was there's no spatial buddy check for the sensors, meaning a sensor in Algona has a temperature of 95 degrees Fahrenheit, but then in Spencer, which isn't too far away, less than 30 minutes, it's 25 degrees Fahrenheit. So we have to figure out, okay, well, what's the threshold that we want to create these buddy check for sensors to make sure, okay, so we can say that the sensor is inaccurate, and so we can put in a 9999, and then in the code, I can say that the data is NA or not available. So we know, okay, well, we need to go and look at that sensor to make sure that the temperature is coming back correctly. Another thing we wanted to do, again, this goes with the geospatial department for the Iowa DOT, is that we wanted as much data open as possible, and we wanted a way to share the ROS images. And before, there was no way to share the ROS images. And then the data feeds failed often due to relational database bottlenecks. So we were going from the sensors out in the field to SQL Server to Oracle, and then to create a view in Oracle, and then to our GIS Oracle, and then up to ArcGIS Online. There was just too many avenues that we took, so we wanted to really shorten that. Okay, then the design. Again, we wanted to make it mobile and tablet friendly. We wanted it easy to maintain, quick to upgrade at no cost. We wanted to make sure that our REST services were highly available. That's why we sent them to the cloud. We wanted a stable environment, make sure that it's cloud-based. So there was less room for error due to upgrades, having to take down the database for cold backups. And then for the final data feeds we came up with for ROS, for atmospheric surface, subsurface, deep probe, traffic, and camera images. And then for the AWAS feed, it's actually coming from the METAR feed, which is a NOAA FAA GeoJSON. And we pull all the METAR feeds throughout the entire country, and then we just actually filter out in FME the ones that pertain to Iowa. And then we wanted to get the county forecast data. And then here, I'm gonna get a little technical and go into the code just to kind of show you actually for geographers and for web developers how simple it is. So what I'm doing here is these are feature collections that we're utilizing, and eventually we're going to actually move to views, but right now we're just grabbing the feature collection. If I click on it, it's actually going to take me to this wonderful looking web page that looks like so much fun to try to parse, and which is actually pretty easy to parse. So this is all the data coming through for RWIS, the atmospheric. And this is just getting the single location, and I'm doing that for each one. So I'm getting the atmospheric, surface, subsurface, the traffic data, the deep probe data, the images, and then the forecast data, and then AWAS. They're all feature collections, and it's very simple to grab them and parse them. And then here's where I'm generating my image slides. And it's just a function that I created that's grabbing each image slide, grabbing its object and the attributes for each image. And each image there's a field. And I'm grabbing the timestamp. And here's where I create the slides. Again, if it's the image for the first one, view it. If not, view the second one, and so on and so forth. And there's 10 total images. I want to scroll down to where, okay. So here is where I'm building my RWIS location table. So it's actually, excuse me. This table right here. And here's where I'm actually using jQuery. I'm doing a for each. So I'm looping through the JSON that I'm pulling from the feature collection, and I'm extracting out its attributes or its features. And for each attribute, I'm grabbing the site number. So whenever you click, there's an on-click event that's calling this point. And that on-click event is grabbing the site number. And then I'm just passing that as a parameter. And then I'm grabbing the visibility, the air temp, all the atmospheric data. And I'm here doing a conditional statement. So if it's equal to 999, then I want the visibility to be NA. And so if I look on the map, I want to see if there's any, actually, let me refresh that. Right now, all the RWIS temps are coming in. So down here, you can see that there's a temperature of NA. Let that load up. Oh, doesn't like that. So I'll let that go. So then whenever I have that 9999, and we put that in for the REST services, so that's easier as a programmer for me to know, okay, if anything's equal to 9999, then I need to put in NA for the user to view. So down here is where I'm building the table. I'm just doing HTML inside of JavaScript, and content RWIS is my table. And then I'm just inputting where on my table I want to put the information. Again, I do the same exact thing, a for each loop, utilizing jQuery to grab my surface information, my subsurface. If I scroll down here, here's where I'm actually creating my forecast table. Again, I'm using jQuery, parsing through the array, grabbing each index and attribute, and setting variables for each field, and then creating a table based on each field. All right. So, oh yeah, so here you can see NA. All right, let me go back to presentation here. So then we wanted to, the implementation. So the code development, we wanted to really focus on ArcGIS API for JavaScript, jQuery, data tables, Dojo, which is kind of a built-in library. It's a library by itself for JavaScript, but Esri really utilizes that in a lot of their applications. And then we wanted JavaScript HTML5 CSS. And Web App Builder, like I mentioned before, I view it as a framework. We wanted to build a prototype to ensure that Tina was happy with. We wanted to do unit testing and have different people testing them outside the DOT, inside the DOT, and on different platforms and devices to validate application functionality. So now what I actually kind of want to do is show you what Mark's FME job looks like. And this is just the AWAS data pool. Minimize that. So as you can see, if I zoom in, this is the METAR site, METAR GeoJSON that we're pulling. And I'll show you that real quick. So copy that, go to the website. So here's what we're pulling. It's just a simple JSON. And what we're doing, we're just parsing whatever IDs that are within the state of Iowa. And then we're just filtering through, or we're setting the precipitation field. We're using transformers, these test filters. You can do if-then statements and elif, checks for cloud cover. And if you're not familiar with FME, FME is an amazing tool to use. It's the Swiss Army knife of data. It really saves our bacon here at the Iowa DOT with our data and how we make it available and how we can clean it up and make it visually great. And then here, query out sensors with date older than 60 minutes. And then we go through, and this is just validating all the data inside the JSON. And then we're reading a CSV that's maintained of the authorized Iowa airports. And here we're writing to AGOL. So if I zoom out to the entire thing, you can see how kind of extravagant it looks. I mean, it's great. And then the ARWIS one, I'll show you. You can see it's a little bit longer, a little bit more in depth here. So if I zoom in, it's pulling from the ScanWeb SQL server where the sensors are being pulled. And then we're just going through, and Mark is just filtering out, doing his algorithms to ensure that the data is correct, using all these different transformers that are able to translate the data, large amounts of data, real-time data, into data that's usable on REST services. So he's doing his calculation for wind speed and wind direction, creates and tests the precipitation types. And then he goes through and continues his formatting and algorithms. And here's the air temp buddy check that he's doing to ensure that temperatures are similar in locations. And then here we are writing to ArcGIS Online again. So there's actually a Python script that's used. There's a folder that all the ARWIS images are pushed to on the server that I access and parse through. It cleans out the directory on FME server. It creates a text file of all the file names and copies those images over to the WeatherView code base folder that I utilize. And then there's FME jobs that run every night to help clear out that folder. So here are the data sources, the ARWIS roadway weather information system, and they're just weather stations that have all the information for atmospheric, surface, subsurface, and deep probe sensors that the state of Iowa DOT maintains. And the vendor actually provides a data feed. And then there's AWAS, Automated Weather Observing System. We pull data for the 43 AWAS sensors in Iowa. And again, the vendor provides data feed to a SQL Server database. But we were doing this, but then we found out that the METAR site has a little more information that we wanted to grab from the National Weather Service and the FAA. So now here are the new AWAS and ARWIS data feeds at data.iowadot.gov. If you haven't checked it out, check it out. Those put together by our group, and it's maintained, and it's a wonderful website to be able to go through and filter out all the data that the Iowa DOT enables the public to use. So one of the things we want to ensure is that the testing and debugging went well. We wanted to make sure, again, that the application worked on all platforms, test on different operating systems, multiple browsers, all the different devices, iPhone, iPad, Galaxy, Note. One of the great things about using Google Chrome is that you can change, what device you are using, as I showed earlier. And the maintenance of it. Again, the maintenance is fairly simple. It's easy. When I code it, I try to make it as simple and clear and concise as possible. The deployment and the maintenance cycle is very easy to maintain. We wanted to, again, do iterative updates. We have actually a share widget on there that anything that you want to critique or maybe add to the website, you can send an email and it goes to Tina, so she can get all those wonderful emails. And then again, we're always trying to continue to refine the back-end process. We have someone here who's kind of looking over our FME processes and maybe utilizing new technology that FME has, new transformers, to maybe speed up the process or at least make it more clear for maybe the next user to come in and try to make changes. Another thing that we utilize is GeoCortex Analytics, and it helps us monitor the application status. So as you can see here, we have sessions by visitor type, new users, returning users, and then we can see who or what browsers are accessing WeatherView, so Firefox, Internet Explorer, Chrome, mobile Safari, and then we can see the devices that are accessing the application. So if they're on desktop, iPhone, iPad, Samsung, and then we can see the peak times and when the application is being utilized. So if there's a major snow event or weather event that's occurring over a certain period of time, we can see when the most traffic is hitting the REST services, and so we can maybe work with Esri to maybe tune the hive that we have our ArcGIS Online services in to help enable us to make sure that our services are highly available. And with that, that's about it. Any questions? Again, thank you so much for coming to this presentation, and you can email me here at cody.barrett@iowadot.us. I'm on Twitter and then my LinkedIn.
Thank you, Cody, and thank you, Danny. So if any of you guys out there have questions, go ahead and type them into the questions toolbar, and we'll open it up to question and answers. And then just as a reminder that the next one is, the next webinar is December 7th, and it's the capability maturity model. Any questions out there? Like, I don't see any hands raised either, so. Okay. I guess we'll end early. Want to thank you guys all for coming, and thank you, Danny and Cody, for presenting. Mark just said cool stuff. Thanks for presenting. Thank you, Mark. So I guess we'll go ahead and end.
All right. Thank you, Nicole,
Thank you,
for
guys.
taking care of everything. Moderating is always nice. So good job. And
Yes.
good presentation, Cody. I really appreciate it. That was nice.
Yeah, thank you. You too. Now, Nicole, I will say that if anybody on the presentation wants assistance in how to grab the METAR site and how we parse it and whatnot, please feel free to contact me. We're more than welcome to help out and kind of show you what we've done.
Okay.
All right. Same goes here.
Thank
You know,
guys.
if anyone has any questions, just emails in the presentation. So please reach out to me. Thank you.
Okay, bye guys.
All right, thanks.